Hence, your position. You already know that. You probably already got it written down, okay? The velocity of the particle, if you will, at time t is the derivative of the position function. So velocity and anytime we have motion problems, it's always with respect to time, always with respect to t. So my velocity function is equal to the derivative of our position function. Acceleration by definition is the derivative of the velocity function. And of course, if acceleration is the derivative of the velocity function, then acceleration is also the second derivative of my position. We also established the fact yesterday, no we didn't, I forgot this too. Speed is the absolute value of your velocity. And that's pretty much what we covered yesterday. If the line of motion is directed positively to the right, then the following motion of the particle is subject to the following at any instant. So, here's what you gotta know. If you know in a particular interval that the velocity is positive, then you can conclude that the particle is moving to the right. If velocity is positive, then we are moving to the right. And the distance, s, is increasing. Work really, really, really hard with the relationships between position, velocity, acceleration. F prime, F double prime, if you will. And concern yourselves with, are we increasing, decreasing? Does that make it positive? Does it make it negative? You gotta get not only what direction are we moving, are we increasing, are we decreasing, are we positive, are we negative? Number 2, if the velocity is negative, then the particle is moving to the left, and your distance s is decreasing. And that's easy enough to understand, kind of straightforward, I think. I hope that's the way your mind is looking at it. Number 2, if your acceleration is positive. If the acceleration is positive, then the velocity is increasing. If the acceleration is positive, that makes velocity increasing. And if the acceleration is negative, then velocity is decreasing. Here's a biggie. Number 3. If the acceleration and velocity are both positive or both negative, the particle will be speeding up. For as long as I've been teaching AP Calculus, there has never not been a problem dealing with, is the particle speeding up or is it slowing down? I guarantee you, in May the 9th, the day that you take your AP exam, which is a couple days after my birthday, I promise you that problem will be on there. They will give you information about particle motion and they will ask you, is it speeding up or is it slowing down? And you'll have to verify how you got your answer. And right there it is. If you know that the velocity and the acceleration have the same sign, then you can conclude that the particle is speeding up. If the acceleration and velocity have opposite signs, then the particle is slowing down. Another twist to that problem is, in what time interval is the particle speeding up? In what time interval is the particle slowing down? And I think there is a problem off of today's homework assignment where they asked about that, but I hadn't shared that with you yet, so how would you know? But now you know. Now you know. And finally, problem number 4. If S is continuous, over time, then the particle reverses its direction whenever the velocity is equal to 0. I don't really like that statement there because that's not necessarily true. Because sometimes you will find in particle motion that the velocity is equal to 0 for a temporary moment, and then it continues on in the same direction. Most of the time, at v equals 0, it changes direction, goes back where it came from. But there's a few instances that I've seen in my experiences where the velocity does indeed equal 0, so you think, oh, it changes direction. No, when you investigate it graphically, analytically, you find out that the particle paused for a second, don't know why, and then it continued on in its same path. So take this statement here, reverses direction, with a little grain of salt, if you will. So with all of this, here's a typical kind of problem that I want to talk you through. Most of it we covered yesterday, some of it we just now covered. I have a particle moving along the line according to the law of S equal 2t cubed minus 9t squared plus 12t minus 4. Last year we had a real major problem with particle motion and the fact that in every problem we would always state this right here and everyone would neglect it. This is extremely important. Please note, in this problem, time can't be negative. It can be equal to 0, but it can't be negative. So don't ever give a negative time for any of your answers that we would ask. And for some reason, most of my calc students last year just always overlooked that part of the statement. So I encourage you, when you read the problem and you see that, underline it. Draw your attention to it. T can't be negative. Okay. Part A. I want to find all values of t for which the distance S is increasing. All I've given you is the position function, and part A, where is this function increasing? Increasing. And what we've got to realize you would never write this down, but you're thinking it. Okay, I'm analyzing the whole scenario of particle motion, and I know that the position increases. That determines when the particle is increasing, if the velocity value is positive. Okay? So now we got to find it. I've got to find where, in this time interval where t is greater than or equal to 0, where is the velocity positive? So the first thing I have to do is find the velocity function, right? And of course, from yesterday we know that the velocity function is equal to 6t squared minus 18t plus 12. There's the velocity. What am I going to do with that velocity? And I'll say this one time. When in doubt, when you don't know what to do and you found the derivative, set it equal to 0 and solve. Set it equal to 0 and solve. You always do that. You always find the derivative of whatever the function is. I don't care if we're calling it velocity or just the derivative. If they ask you anything else about it, set the derivative equal to 0. In other words, I'm going to find where the particle possibly changes direction. And that occurs when the velocity is equal to 0. So I'm going to take 6t squared minus 18t plus 12, and I set it equal to 0. Solve for time. At what time does this particle change direction? We'll factor out a 6. T squared minus 3t plus 2 equals 0. T minus 2. T minus 1. So at t equal 2, t equal 1. On a real number line, I'm going to draw myself a little sketch. I'm going to look at the interval. Because of this, I have to start at 0 to 1, because at 1 I know the velocity is equal to 0. And then at 2, because I know the velocity is equal to 0. And then everything greater than 2. So I'm looking at the compound inequality, 0 less than or equal to t less than or equal to 1, 1 less than or equal to t less than or equal to 2, and t greater than or equal to 2. I want to test these intervals. I want to know, is the velocity positive or is the velocity value negative for each of these intervals? So pick a point in the interval and evaluate your velocity function. And I find that the velocity is positive in the interval from 0 to 1. The velocity turns out to be negative in the interval from 1 to 2. And for all times greater than 2, it's positive. Again, remember what we said here. The position is increasing when the velocity is positive. Now it's as clear as mud from the little chart. You know exactly where that particle is increasing, because I know the velocity is positive in this interval and in that interval. So my answer particle is increasing from 0 to 1 and excuse me. So there's one, part A. There's a whole bunch of parts to this problem, so be patient. Any question on what we did here, though? Okay? This is what you have got to learn. You have got to remember that the position of a particle is increasing when the velocity is positive, decreasing when the velocity is negative. You just got to know that. Moving on. Part B. We want to of time for which the velocity is increasing. Now, part A, we ask, when was the particle increasing? Now we're just flat out asking you, when is the velocity increasing? But don't we already have that answer? Sure. So I don't have to do anything, just to answer it. The velocity increases when your velocity is positive, and we know that the velocity is positive in these two intervals. Part C. And what you must remember is that we're speeding up when acceleration and velocity have the same sign. So, I know that the velocity is 6t squared minus 18t plus 12. Acceleration is equal to what?
Derivative
Of
velocity.
the derivative of velocity. So I've got to find my acceleration, which is going to be 12t minus 18. I need to find the points, the times, where the acceleration changes. So what do? Well, I found the derivative. I'm going to set it equal to 0 and solve. So 12t minus 18 equals 0. And where did I do that work at? 12t is 18. T is 3/2. So on the real number line, for time, my time number line starts at 0, then something happens at 3/2 with respect to the acceleration. So I'm looking at the interval from 0 to 3/2 and greater than 3/2. Determine if the acceleration is positive or negative in each of those intervals. Again, pick a point in the interval, evaluate your derivative, and all I'm concerned with, I don't care what the value is, I'm just concerned with, is it positive or is it negative? And cutting to the chase, we find that the acceleration is negative in the interval from 0 to 3/2, and we are positive in the interval for all values of t greater than 3/2. Okay? So I know where my acceleration is positive and negative. I know where my velocity is positive and negative. Now I got to put the two together. So I'm going to put together another timeline that starts at 0 to 1 to 3/2 to 2. Because at 1 and 2, the velocity is equal to 0. At 3/2, the acceleration is equal to 0. We already found that in the interval from 0 to 1, the velocity was positive. From 1 to 1.5, the velocity's got to be negative. From 1.5 to 2, 1.5 is still negative, and for greater than 2, it's positive. I know that from 0 to 3/2, the acceleration is negative. So negative, negative, positive, positive. Now finally, after all that work, I can answer the question, where is the particle speeding up? The particle is speeding up in the intervals where the velocity and the acceleration have the same sign. Well, they have the same sign here and here. So we say that we are speeding up from 1 to 3/2 and everything greater than 2. Like I said, the College Board likes that question there. They like to ask you, when they give you a position function, where is the particle speeding up or where is it slowing down? And you've got to do all of this work. You just can't guesstimate it. You gotta find where your velocity function is positive, negative, where the acceleration function is positive and negative, and then remember the relationship between the two. If the signs are the same, you're speeding up. If the signs are opposite, you're slowing down. Part D. Find the speed when t is equal to 3/2. What do you need to know for this question? Well, you need to know that speed is the absolute value of the velocity. So that tells me I need to find the velocity at t equal 3/2, and then simply take the absolute value of my answer. That's one of the easiest questions out of the whole set. So again, my velocity function, we had velocity is equal to 6t squared minus 18t plus 12. So I need to find the velocity when t is equal to 3/2. And when we chunk every term, so I've got 6 times 3/2 cubed minus 18 times 3/2 plus 12. I get negative 3/2. You can check my arithmetic. Oops. And of course, we all know that the absolute value of negative 3/2 is 3/2. And then finally, find the total distance that this particle has traveled. Now you got to realize it's been going to the right and then back to the left, then to the right and then back to the, it's been left and right all over the place. So let's take the time interval from 0 to 4. From 0 to 4. So the first thing I need to do, I need to find the distance traveled at each of these time intervals, 0, 1, 2, 3, and 4 seconds. At t equals 0, we're at negative 4. At t equal 1, the position of my particle is at 1. At t equal 2, I'm at 0. T equal 3, I'm at 5. And at t equal 4, I'm at 28. Again, all I did was I took these time intervals and I put them back into the position function. Not the velocity function, not the acceleration function, but back to the original position function. So from the time interval 0 to 1, we traveled negative 4 minus 1, 5 units. From a negative 4 to a positive 1 is 5 units. How do you get that? Find the difference of the two terms, take the absolute value of that. From 1 to 2, I've got 1 minus 0, which is 1. From 2 to 3, we traveled a total distance of 0 minus 5, which is 5. And from 3 to 4 seconds, I can quit now, we went 5 minus 28, whoops, and I get 23. 23, 34. In 4 seconds, this particle has traveled, going left and right, going horizontally, 34 different units, or 34 units. Maybe not one of your favorite kind of problems, but it's got to become one of your favorites. You've got to become an expert with particle motion problems. And I guarantee you one of our Saturday sessions will be dedicated to nothing but particle motion. It's one of those topics that I guarantee will be represented multiple times on the AP exam. And I guarantee you it will be in both free response and multiple choice. So we will be working a lot with particle motion. There's a lot involved. But like I said, the College Board really likes this particular type of problem. So as an AP student preparing for the AP exam, you got to become an expert with this type of problem. Okay? What I have for you for tomorrow is a Gladys Wood